Good morning, ladies and gentlemen. Welcome to the Cotecna Talkshow. My name is Dean Tilbrook and I'm the Global HSE Officer. It's my pleasure to introduce to you a distinguished panel of experts who are leaders in the field of food safety and quality assurance. Our first speaker is Henry de Vallicourt, Vice President of Food at Cotecna. Henry has a wealth of experience in the food industry, having held senior positions in several multinational and TIC companies. He is an expert in food safety and quality assurance, and has been instrumental in developing and implementing innovative solutions to ensure the safety and quality of food products. Next, we have Willem Brouwer, Manager of Science and Development at Nofilab, a leading analytical laboratory specializing in food and feed analysis in the Netherlands. Nofilab has been part of Cotecna since 2017. With over 25 years of experience in analytical chemistry and food science, Wim is a renowned expert in food analysis and is known for his innovative approach to solving complex analytical problems. Our third speaker is Suresh Babu, a leading expert in food safety at Geochem. Geochem recently joined the Cotecna family and is a global testing and inspection company that provides a comprehensive range of services to the food industry. With over 20 years of experience in the field, Suresh has a deep understanding of the challenges faced by the food industry in ensuring the safety and quality of food products. Finally, we have Francisco Pio Principi and Cristina Ferretti from Neutron, a leading laboratory providing analytical testing and consultancy services to the food and pharma industry. Neutron has been part of Cotecna since 2019. Pio and Cristina are experts in food chemistry and food safety and have extensive experience in developing and validating analytical methods for detecting contaminants and other harmful substances in food products. Our panel of experts is well versed in food safety and quality assurance with a wealth of knowledge to share. Henri will lead the discussion, introducing the framework and trends relating to emerging issues like PFAS and the new technologies such as NGS. So everybody get ready for an enlightening discussion. And over to you, Henri.
Thank you very much, Dean, for your words of introduction. Good morning and good afternoon, ladies and gentlemen. I'm truly glad and honored to welcome you at our talk show dedicated to food safety today. You will see through some illustration how Cotecna is developing a very broad range of expertise across the board to deliver the best service to each of its customers. But before going further, what is new in food safety in 2023? To answer this difficult question, I think we should look at the course of the last 3 years and consider the exceptional disruptions that hit the world, but that hit also the food and feed chain. First, the pandemic. First, the COVID pandemic has stressed the food supply chain in many areas. But let's acknowledge that this crisis has been quite successfully overcome by all food stakeholders. However, this world crisis has also demonstrated how more resilient a short and qualitative food supply chain can be in such unanticipated circumstances. Later on in 2022, a regional conflict in Ukraine has triggered an unparalleled price inflation period in many geographies across the world. But beyond inflation, war in Ukraine has also led to shortage on key food raw materials like wheat, grains, or oilseeds. And I consider that this second shot has hit very strongly and more strongly the food supply chain than the COVID crisis. Indeed, the consequences of this local conflict has been global. And let's take one illustration. I would pick the case of palm oil. The need for replacement of missing quantities of oilseeds coming from the war area has led to the sudden surge of palm oil demand in the world, leading to the export ban decided by Indonesia, who has privileged its domestic market. But beyond this example, and more generally, many food companies and governments across the world have suddenly turned their priority into food security in order to supply population with essential foods. But you can wonder, in this context, what about food safety? Does food security cancel any sort of food safety concerns? And of course not. Of course not, and we are all together here for this reason, and I think this is what we should all pay attention to. Let's elaborate a little bit on it. As the food supply chain was under a strong stress during this period, The risk related to contamination by chemicals compounds, by bacteria, toxins, have not magically disappeared or even decreased. Even worse, in time of supply disruption, new sources of supply has been set up very rapidly to cope with unanticipated shortage. And you can easily imagine that switching oilseed supply from Ukraine to Argentina or Brazil may raise new questions about GMO control or pesticide controls. Indeed, importing food raw material from one continent to another raises lots of questions about the regulation that must be checked and applied. Each regulation are different in every region. So, as an example, we will present the case of rice regulation with our new colleagues from Geochem in India in a few minutes. Furthermore, in time of inflation and food supply shortage, fraud and adulteration become more and more profitable. Fraudsters have more and more opportunities to sell at best just adulterated food with inauthentic ingredients, or at worst, contaminated and hazardous foodstuff. In that respect, we are very excited to present today with our colleagues from Neutron what the next generation sequencing technologies can provide to monitor and better secure food authenticity. Finally, in addition on already existing food safety risks that are very well known, such as foodborne diseases, pesticides, and again, dioxins contamination, there are also the surge of new sort of risks. For example, there are more and more concerns about mineral oil migrating from industrial processes or from food contact materials. And in this regard, mineral oil saturated hydrocarbons and mineral oil aromatic hydrocarbons, known as MOSH and MOA, are now a hot topic, and testing methods are far more complex than the one used to test the smaller molecules. And our colleague Wim Broer at NOFA could elaborate a little bit during the Q&A session. Another example that we will discuss today are PFAS, in other words, per and polyfluoroalkyl compounds that are chemicals used by various industries. They are called usually forever chemicals, and they do not decompose over time in the soil and then contaminate livestock or human food as a result. And our lab Neutron has been at the forefront of the research to anticipate this risk, and our colleagues are going to tell you a little bit more about this very hot topic and the methods that are available to cope with this new risk. But before handing over the micro to my colleagues, I would like to highlight how important and to remind you how important it is to keep food safety at the core of any business decision within the food industry. And I'm proud to say that Cotecna today is working very hard to propose the best solution to its customer wherever that can be located and whatever the issues they are facing. So I'm thanking you very much, and I'm very happy now to hand over the micro to my colleagues. Thank you.
Thank you for that excellent introduction, Henri. So during the food show, our Neutron and NOFA experts will provide valuable insights into how advanced technology can be used to detect and mitigate the presence of PFAS in the food supply chain. With recent implementation of European Union regulations mandating the testing of animal products for PFAS contamination, the information shared by our experts is more critical than ever. Our experts will discuss how Neutron Laboratory, a leader in PFAS testing, has attained the ISO 17025 accreditation for the detection of PFAS in various food products such as waters, animal tissue, eggs, and derivatives. He will also explain how this technology has been used to identify and monitor PFAS contamination in food products, thus ensuring compliance with the latest EU regulations. In addition, our experts will present a case study regarding the application of Neutron's PFAS detection method. They will provide insights into how the analytical method can be used as a tool and strategy to mitigate PFAS contamination. So a question for Pio. Is the PFAS contamination issue something new, or did we also have this issue in the past?
Hello to everybody. Thank you, Dean, and thanks to my colleagues for inviting me in this talk show. PFAS are for sure emerging contaminants, but the story starts many years ago. The first time we performed the PFAS analysis in neutron was more than 10 years ago, maybe 2013 or something like that. And the reason was because of migration PFAS migration from cooking tools. The pan used for cooking are sometimes coated with Teflon, a plastic material produced using PFAS, and in this material, some traces of PFAS can be present as residues. The second high-impact event for Neutron regarding PFAS analysis was in 2018, when the Italian ministry started an investigation on groundwater in a region of northern Italy and found an heavy and wide PFAS contamination due to illegal waste of fluids from a plant that used PFAS in production process. So to make the long story short, in the last 10 years, EFSA and other international institutions published several opinions and investigations about PFAS contamination and their toxicity. And all these researches lead at the beginning of 2023, the European Commission set maximum limit for PFAS in meat, fish, and eggs. Please.
So following on from that, what are the trends you're observing in PFAS testing?
The regulation entered in force in beginning of 2023, has been the turning point for PFAS analysis because control plans of the majority of food companies are driven by regulation, and consequently the number of samples to be tested is still growing now. In my opinion, this increase in testing activity is positive because putting the spotlight on these contaminants and testing samples is the first step to understand, to measure the magnitude of this problem and take action. If you know, you can decide. If you don't know, you think to decide. So finding samples with a high level of PFAS usually trigger investigations customer side requiring additional testing.
Can you share a case study of the PFAS investigation triggered by non-compliant results?
Yes, just to give you an example, we found high levels of PFAS in eggs samples coming from a specific farm. And the customer decided to start an investigation extending the analytical controls on many other egg samples, but also testing meat, feed, and water used in this farm. This investigation led them to understand that the groundwater used was the source of contamination.
Were there any challenges or obstacles encountered during the development of the PFAS detection methods?
Okay, the main challenge was surely related to the very low limit of quantification of the method. In the regulation 1881/2006, updated at the end of 2022, we had for the first time defined the maximum residue limits, MRL, for PFAS. MRL have an impact on the limit of quantification of the method used. The limit of quantification must be lower than the MRL in order to generate results useful to evaluate the compliance on samples tested with the regulation. Neutron PFAS accredited method for fish, meat, and eggs have a limit of quantification of 0.1 microgram per kilos, or ppb, part per billions. The limit of quantification is the minimum amount of contamination that the method is able to detect in the samples analyzed. So all negative results are not zero as concentration, but always the result will be lower than the limit of quantification. Just to give you an idea about the order of magnitude of this limit of quantification, imagine that our sample is the whole world population, and we have to find one single special person. Well, a method with a limit of quantification of 0.1 ppb will be able to find him among all other people. So developing such analytical method has been a challenge because PFAS are also environmental contaminants. And when you lower the threshold so much, you start to find contaminants also, for example, in reagents and equipment used in the lab.
And what do you think is the future of PFAS testing activities and the scenarios that it's going to be used in?
It is too early saying that PFAS will be the new dioxins, and if this issue will be disrupting for stakeholders. But we can simplify and consider two different scenarios. The first one is when an emerging contaminant fade out after the initial boom in testing activity, like melamine in Chinese milk during 2008 or fipronil in eggs in 2017. The second scenario is when testing activities persist even after the initial boom, such as the case of dioxins many years ago, or more recently ethylene oxide or pyrrolizidine alkaloids contaminants in botanicals in 2020. The main factor, the key factor to determine which of these two scenarios we will see is the level of PFAS contamination the labs will find testing samples in the incoming months. PFAS are a very persistent contaminants that accumulate along the food chain. So I think that the ongoing focus the European Commission put on them is very important for the health of the community.
Thanks very much. And now we have a question for Wim. Wim, what is the background and current status of the PFAS testing activity at NOFA Labs, including the testing methods that you're using and the scope of the testing services offered, and any plans for the future development or expansion of the testing program that you have? Sorry, Wim, your microphone seems to be off.
Well, we had a validated PFAS method back in 2018, which worked excellent on the QTOF. But when we had a fire in 2020, we did not extend that application. So now we are middle in the validation of the PFAS in several commodities. Also the fish and the eggs, of course, but also in edible oil, lecithin, where it could be concentrated in the end. And I think there will be emerging in those types of commodities.
Thank you, Wim. And now I've got a question for Suresh Babu. What is the current situation regarding the PFAS contamination in India, including the extent of the problem, the source of the contamination, and any regulatory or remediation efforts that are being undertaken to address it? Sorry, Suresh, we can't hear you.
Yes, Dean. Thank you for the question. Yeah. In the Indian scenario, the Indian regulators are not thought about any implementation at this point of time. However, India does a lot of exports. So India is the export side very keenly watching the scenarios emerging in the international market like Europe and US and all, where there is a regulations place. So very soon, the same thing will be applied for the export purpose. That's what I'm expecting on this particular case. As part of the geochem, which is also when the regulation become mandate, we will be getting ready for offering these services to the customers for who is exporting it. As and when the domestic market regulations are coming, we will be also implementing that same thing in India.
Excellent. Thank you very much.
Thank you.
Today, we'll be delving into the fascinating world of next generation sequencing, NGS, and its significant impact on the food industry. As a pro for technology, NGS has revolutionized the way we study DNA and genetic variation. In the food sector, NGS has numerous applications, including improving food safety, authenticity, traceability, and enhancing crop production and sustainability. Neutron provides accurate and reliable NGS species identification services. Using NDA, they can learn and identify the species of vegetable, animal, and fish in raw goods and complex matrices. Let's learn more about this analysis and its critical role in ensuring the safety and authenticity of our food. Got some questions for Christina. How can NGS be used to verify the authenticity of food products, and what are some of the examples of this in practice?
Thank you, Dean, and thank Cotecna for the invitation. I'm very pleased to take part in this talk show. My name is Cristina Ferretti. I've been working in Neotron for 23 years, and currently I'm division manager of molecular biology and microbiology departments. Food authenticity is a big concern for consumers, food producers, and food authorities, since mislabeling of food products and other types of counterfeiting have been demonstrated to negatively affect the confidence and even the safety of the final consumer. An example of a common food fraud is the substitution of one ingredient by a similar and cheaper one. And different analytical procedures can be used for the identification of these food adulteration, including spectroscopic, chromatographic, and proteomic approaches. However, in many cases, the fraud is based on the substitution of one ingredient with another that is a different species, and for these DNA-based methodologies have been shown to be an ideal tool to deal with the problem. For example, oregano, that is a widely used herb, is particularly vulnerable to fraud and can be adulterated with olive, myrtle, marjoram, and other leaves. Pepper was found to be adulterated with different cereals starches, but also with mustard that is an allergen. This makes understand that food authenticity and food safety can be closely related. Consumers expect that the food products are correctly labeled, as this may also have health implications, for example, to avoid allergic reactions. And NGS has the power to deal with many issues in authenticity and food safety.
So what are the key benefits of using NGS in food safety testing compared to the traditional methods?
Well, the majority of DNA-based methods, real-time PCR, LAMP, digital PCR, and Sanger sequencing, amplify specific area of DNA and allow the amplification of a small fragment, which is subsequently used as a molecular marker. These methods are used frequently for routine analysis, but they have some limitations as they require a prior knowledge of which ingredients might be present, limiting their use as screening tools for unsuspected ingredients. The advantage of NGS is the ability to simultaneously screen multiple different genomic regions to enable the identification of all plant and animal ingredients in food products, and this is called metabarcoding. NGS indeed can scan for thousands of species simultaneously, unlike traditional Sanger method that sequences a single DNA fragment at a time. With NGS, each single molecule is sequenced independently, allowing assessment of complex mixtures when a complete picture of the ingredients and contaminants is required.
So I believe that it can be used in the microbiological identification of bacteria, but what other applications does NGS have?
Yes, within food safety, NGS is already used for the identification and detection of foodborne pathogens. It is used in understanding food spoilage and in identification of microbial NGS applications, as it allows the identification of plant, fish, and meat species in complex foods. From our experience in species identification, DNA metabarcoding is particularly relevant for matrices such as meat, fish, and fish products. Fish is highly vulnerable to mislabeling among food products. Dairy products, pet foods, animal feed, herbs and spices, but also herbal supplements and medicinal plants. In fact, these products are particularly subject to adulteration because of their very fragmented supply chain And in this case, the substitution can be intended or non-intended as possible cross-contamination with the other species, growing, the harvesting, the manufacturing, or the handling. In any case, it is necessary to pay attention to the results obtained, as in some cases, the species can be toxic.
It's absolutely fascinating. Thank you very much, Christina. And now I'd like to ask Suresh, what are the specific measures and technologies that are taking place at Geochem to employ and ensure the authenticity of seafood and spices in India, and how effective have these methods been?
Thank you, Dean. The adulteration is becoming a very major issues across the globe in the food safety supply chain. One is the availability, and another one is the cost conflict. So the people try to do certain areas when the availability is less, try and use the cheaper varieties or cheaper alternates to adulterate it, intentional adulteration. Another one is the cross contamination takes place. But as a consumers, in the interest of the food safety, the regulators also stepping in and playing a large role. That's how the laboratories like us in the food safety supply chain trying to help the industry and the consumers and the regulators to get the right quality, safe products in the market. So we are having a facility to identify the authenticity of the various foods, include by using the real-time PCR currently, and also identifying various species level identification in the food. And we are supporting the industry. The regulations point of view in India, it's not much implemented in the domestic regulation. However, the export market, the fish and fishery product, the spices, the rice varieties, these identification requirements are their authenticity, which Geochem is able to serve the customers in terms of meeting their requirements.
Thank you very much, Suresh. So rice is a crucial dietary staple for a significant portion of the global population, particularly in Asia. However, there are growing concerns about the safety of rice due to the presence of inorganic substances. As a result, various regulations and control measures have been implemented worldwide, including in India. In this discussion, we'll explore the different regulations and control measures for rice safety across the globe and compare India's approach to other countries. Additionally, we'll delve into the role of companies like Geochem Laboratories in ensuring rice safety. As part of Cotecna, since this year, Geochem Laboratories is dedicated to helping rice producers comply with the safety regulations by conducting reliable and precise testing for contaminants. With their expertise, Geochem Laboratories plays a critical role in ensuring rice producers follow regulations and conduct thorough testing to guarantee the safety of their products. Join us as we explore the vital services provided by Geochem Laboratories, NOFA and Neutron, and how they contribute to addressing the challenges of rice safety. So, Suresh, how do the regulations and control measures for rice safety vary across different countries and regions? And is there a trend towards harmonizing the regulations across these countries and regions to ensure a consistent level of safety for consumers?
Thank you, Dean. The rice is a very interesting, one of the staple food consumed, especially by and large in the Asian regions. The worldwide global production for rice is close to 500 million metric tons, out of which close to 24% is produced in India, 28% is produced by China, and rest all is in the single digits. The population-wise, China and India is the leading population countries in the world. So the consumption is also very large. 30% produced is consumed by China, 21% produced by India is also consumed by domestic level. However, the surplus quantities are going into the areas where the rice is not much grown. So the major importing countries are sub-Saharan African countries, the Middle East countries, Southeast Asia, East Asia, and yes, it goes to the US continent as well as the European continents. The regulation wise, when you look at it, in the interest of consumer safety, by and large, the less producing countries are having a very stringent norms. The European countries, the US, markets are having a very strong requirements in the consumer interest. The producing countries are having implementations comparatively less stringent than these countries. The major issues today is that in the cultivations of rice, due to the geographical conditions, the climatic scenarios, these producing countries are not able to produce it by avoiding certain cross contamination or the process contaminations which is taking place by using a various pesticide residues, pesticides and other thing which is contributing to the contaminations into this rice. Especially the inorganic arsenic is one of the growing concern globally. However, this growing concern is not harmonized across the globe. There are certain countries who talks about the total arsenic which is required 0.2 milligram per kg to be monitored. There are some countries which is talking about 1 milligram per kg. There are certain countries who is talking about 0.35 milligram per kg. And in India, the total arsenic is only the monitored. The European and other countries which required inorganic arsenic, which is a more carcinogenic part of the total arsenic. So the regulation wise, if you look at it, it is not well harmonized across the globe. At various forums, we are raising this point with respect to whether it is the inorganic residues or the pesticide residues or other contaminations. We are making a point to bring a harmonization in the regulations. Yes, that is a long drawn dream which is going to take place. It's one sweet time to get harmonized on all those things. However, at this point of time, the industry and the supply chain is trying to meet the destination market requirements. As a geochem, across India, we are having a presence of almost 40 locations, whether the rice producing areas, the rice processing areas, the rice trading areas, and the hubs of exports, the port areas, where geochem is present for drawing the samples from the farm levels or at the processing factories level or at the warehouse level or at the port level when the vessels are moving out from the country. So we are offering the inspection, sampling, and the testing. The laboratories are having a qualified accredited laboratories are available for testing the pesticide contaminations, the inorganic arsenic, the total arsenic, as per the demanding requirements of the destination markets. We are offering these services to the industry trade and ensure that the consumer safety is complied in those countries when the goods are reaching their destination.
Thank you. And how can the standardization of consistency in testing methods be improved to ensure accurate results and compliance with these regulations?
Right, Dean. So the results which required well replicated wherever it is getting tested, it is what is the ideal requirements so that there is no issues in the supply chain or the trade. So the ISO IEC 17025 accreditation, which helps to harmonize the method of analysis and standardized and providing the test requirements are given the things. So those aspects of that, the methods are properly validated by the laboratories. The sampling is done rightly as per the international practices by across the globe. And the results are also verified through various proficiency testing participation and seeing that the laboratory results are very much aligned across the globe. That's how we ensure that the analytical methods are properly harmonized and validated and used for the correct results.
That's excellent. Thank you very much. I know we've got some questions that have come in. So I believe the first question is for Christina. It's regarding NGS. And the question is, how complex is the implementation of these technologies? Do they require new skills for the molecular biology teams performing the NGS, such as bioinformatics and biostatistics?
Currently, NGS requires highly specialized equipment and a skilled staff to analyze the data. A critical point is the availability of effective tools and databases for data elaboration, and bioinformatics can provide a decisive contribution to this. However, NGS has been incorporated into routine analysis for authenticity and contamination, and customers have started to rely on this technology to identify adulterants.
And there's another question on the same subject as well. We have, is NGS qualitative or quantitative?
Okay, for the application that we have been shown before, so the identification of ingredients in complex mixtures, NGS can be used only for a qualitative purpose, as it screens for undeclared ingredients. Then NGS can be combined with other techniques that provide the quantification of the species previously found.
Excellent. Thank you, Christina. And we've got a question for Suresh. Is there any direct relation between the rising cancer rates and rice consumption globally?
Very good. It's a very interesting thing. The population-wise and the cancer cases where the rice consuming countries, if you look at it, the production and consuming countries, it's a very negligible amount. However, as part of the things, the science which has identified that the carcinogenic compounds are present in the rice, which we can't also ignore it. So there is a lot of studies are required to correlate the existing present on that. However, there are two school of thoughts are present. One school of thought still says that the rice is also one of the contributor due to the inorganic arsenic present in that. But when you look at the statistics, which is not showing a direct proposition to have the things, but we should not ignore that possibility of any contaminants is harmful, which should we think of eliminating from the food safety point of view.
And there's another related question that you could probably answer as well, Suresh. How do companies like Geochem Laboratories, NOFA and Neutron contribute to ensuring the safety of rice and other food products?
The safety of the food products, whatever the regulation point of view, the countries which is implementing is adopted by the laboratories, and we are ensuring that providing the same kind of requirement that tests are happened and issue the results are meeting the requirements. Harmonization is point of view, it is done on that way.
Excellent. Thank you very much, Suresh. And I've got a question on PFAS, which I think will be for Pio. What can a lab do in order to be ready to provide suitable testing services in case of alerts or new regulations?
Okay, very good questions. A very good question. Well, there are, I think, several strategies that a lab can put in place to be ready in case of food alerts or new regulation. I think that for Neutron, for example, a wide analytical portfolio and the participation to different scientific networks are two key factors which bring us to provide suitable and effective testing services in case of food alerts.
Excellent. Thanks very much, Pio. And I've got a question for Henri. How does the Ukrainian situation impact the global food supply? And do you see increasing famine in the most vulnerable geographic areas in the coming years, considering the current future crop losses?
Indeed, it's a tough question, and I'm not maybe able to foresee the future with all the accuracy you can expect. But what we can see is that the capability of of all countries, and especially also Ukraine, to adapt its food production, crops, to the new situation is quite impressive. And I believe, and there is also talks to allow crops to be done, to be performed, whatever happens in Ukraine. So I believe that the situation should improve months after months. We can expect that the situation would improve also in Ukraine. And so I believe, but it's only my own belief, that the situation will be better and better, that all stakeholders have developed new source of supplies, has also put in place new patterns of food safety control. And I would expect that if there is any new crisis, any unexpected weather crisis too, floods or wave of warmth, we can expect that the situation will be improved even in more vulnerable part of the world. But it's just my my own view, and we still have to be very careful to adapt and to be flexible, and as we are Cotecna, to be very reactive in order to cope with new situation and able to provide the tools to anyone that needs to change his supply from one source to another, to supply with expertise, with tests and regulation information to adapt its strategy.
Thanks very much, Henri. I think this next question might be for Wim. Somebody is asking, I would like more information about MOSH and MOA regulation and laboratory control methods.
Well, MOSH MOA, a very interesting subject, which is already around us from the end of the 90s of the last century. And it was really booming after 2006 with an adulteration of sunflower oil from the Ukraine. But there were test methods back then, but the method was very prone to interferences. So it took a long time to really develop the right method. And that was established really last year. And which gave a good, a low LOQ enough, where all interferences, which might be in natural products like terpenes, olefins, waxes, and so. The method is now that way that you don't measure them that much as an interference, but still there are interferences. In the legislation side, last year, the EU Standing Committee put MOLs of MOA in samples, lower than 10.2 for oil, pure oil, until 50% of oil. Below that, 1, and in dry products, only 1 milligram per kilo. That's in place now, and in Europe, they should react on that.
I think sorry, Wim, I've got a related question as well, which I think is to do with the same subject. I've got a question regarding the requirements that are set for plastic converters regarding PFAS and MOSH.
Ooh, that's a very good question, and I didn't think about it until now. You asked the question. I don't think there is a real relation between PFAS and MOSH, because they have different sources. Of course, they could be together, but they are totally different sources. PFAS is completely environmental contamination in food, while MOSH MOA could be from the environment, but also of the solvents used, lubricants used during the process. So it's not only an environmental pollutant, but also a process contamination.
Excellent, thanks very much. I think we've got time to go over to some open questions. If anybody would like to put their hand up, if anybody's got a question they would like to ask. Anybody in the audience? Don't see anyone with their hand up yet. Does anybody have any other questions? Okay, if nobody's got any other questions, I think we can go over to Henri for the conclusion.
Yes, thank you very much, Tim. Thank you for having coordinated this presentation. As you can see, Cotecna is not just one company based in Switzerland, but it is a network of laboratories, of companies able to perform a very large scope of service in the field of the food safety. I was very happy that our team has been able to present to you what we can do, what we are doing, and to prove to you that how reactive, flexible we are facing new challenges, as you are facing new challenges in the food safety field. I think we have to stay very humble because every day brings its new lots of unexpected events. And our goal at Cotecna is to remain very close to you, to our customers, to the field, to understand what happens, and to keep also our scientific spirit, our and mindset that is now really necessary today to implement all the new source of technologies, all the new technologies that help us to propose you the best way to monitor your food safety risk. And I am also very proud also to introduce you today to some of our new colleagues that are coming from, for instance, today it's from Geochem in India with Suresh Babu, and I hope that in the coming months there will be also some new colleagues that will join our networks, because we intend still to grow, not just to become bigger, but to bring you new technologies, new areas of expertise, and new locations where we can provide very valuable services. So again, thank you very much for the work that has been done by all the team, the communication team, and Dean, and all the laboratories that took part to this nice talk show. I'm still, and we are all still open to any question coming from you. Any of you, you can contact us through the channel that you have used to subscribe to this talk show, and we will be always happy to answer your questions and elaborate a little bit about the topic we have discussed today. So again, thank you very much. Wish you a good day, a good night for the one that are later on the day, and hope to see you very, very soon in one of our events that we will for sure plan in the future. Thank you, and bye-bye.